Hello everyone, welcome to Olsen Cafe. Today, I am going to go through a classic probability question that catches a lot of students off guard. Now, what is the probability, right, that a card drawn is either an ace or a red card? Now, many jump to a quick answer and get it wrong. So let's find out why. So before we begin, let's go through some of the basic knowledge that we need to know about the playing cards. Yeah, in a deck of cards, all right, we know that there are four different types, all right, the four suites. So namely the black cards, all right, which are spades, clubs, and the red cards, which is diamonds and hearts. Now, in each suite, there are total 13 cards. So in each standard deck of playing cards, all right, we know that the total number of sample space, right, in this case is 52. So if we start off with a very basic question, all right, to find the probability that the card drawn is an ace, is actually very simple. It's simply, we know that there are four ace cards, all right, and then to find the probability, therefore it is simply just 4 out of 52 and then reduce to the simplest form. This will give us 1 out of 13. Now, this is very simple. Now, how about to get the probability of an ace or a red card? Now, let's take a look. How many red cards are there? So we do know that to get the red cards total, there are 26 cards. So therefore, in order for us to find the ace or the red cards, do we really take 4 ace cards plus 26 red cards? So is this really true? So in order for us to find the probability, we will need to understand some concept behind, right, which is what I'm going to go through with you. So first of all, let's take a look at this example. All right, what is the probability of getting an ace or a king? Now let's take a look using some diagram. So we have here, all right, we do have the number of ace cards, which is there are 4, and the number of kings that we have, there are also 4. So in order for us to find the probability of getting an ace or a king, right, it is pretty straightforward. It's simply there are 4 ace cards plus there are 4 kings, right? So therefore, I just take 4 plus 4 and out of the total sample space, which is 52. So to do this, all right, I simply add them together and I will be able to get the answer, which is 2 out of 13. Now for this case, I would like all of you to observe, all right, is there a common element between the two sets? All right, so over here you notice that there is no intersection here. So which means in this case, all right, for me to add the two cards, all right, the two probability, it is straightforward. All right, so therefore I can do this, all right, if I just want to find probability of ace or a king, I can simply just add the two probability. All right, so this can be done, all right, because there is no common element, there is no intersection over here. Let's take a look at another scenario. So what if now I want to find the probability of getting a heart or a king? Now let's again use set diagram to help us to visualize. So over here, total I have 13 hearts and I have 4 kings. Now, in order for us to find the probability of getting a heart or a king, do I really add up the 13 plus 4? So which means if I just add these two together, I will get 17 out of 52. Now, is this true or false? But if you take a closer look at the total elements here in these two sets, you will notice that I will only have 13 hearts plus 3 kings here, right? You notice that one king, all right, there's a king of hearts. It is actually in the intersection. So that means total there are only 16 elements instead of 17. All right, so in this case, I will not be able to work it out as 17 over 52. Why? Because there is, all right, a common element between the two sets. So therefore, all right, in order for us to find the probability of the heart and king, heart or king, I do need to take note that the total number of elements, all right, there's only 16. So therefore, when I simplify, the answer should be 4 out of 13. Now, so in this case, all right, what we need to take note that even though, all right, in the probability we are asked to find heart or king, we cannot simply, right, just add the two elements together. So we cannot blindly add them unless they are mutually exclusive. So over here in this case, hearts and kings, right, in this case, they are not mutually exclusive, right, which means there is a common element. So therefore, all right, before we actually just add the two probability together, all right, we do need to ensure, all right, that the two events are mutually exclusive. So which means they cannot happen at the same time. So therefore, in this case, all right, in order for A, all right, to find probability of A or B, all right, what I need to ensure is that there is no common element. So let's take a look at another example over here. So in this scenario, do you think that this is a mutually or non-mutually exclusive event? Right? Notice that there is a common element here. All right. So if there is a common element, all right, which means, all right, it is a non-mutually exclusive event. So therefore, in the concept of probability, right, one of the most confusing concept that students often make mistake, right, it will be in the addition of probability. All right, so do take note that before you can even add two probability together, right, it is important for us to check whether the two events are mutually exclusive or non-mutually exclusive. So therefore, you can only add the two probability together provided that they are mutually exclusive event. All right, so for non-mutually exclusive event, all right, we cannot just simply add them together. So what we do need to do is we do need to subtract the intersection. So let's come back to the very first question. What is the probability of getting an ace or a red card? Now, for such case, one important question that we need to ask ourselves will be, are they mutually exclusive? All right, so we apply this concept whenever we see the word or, all right, ace or red card. So for such case, do you think they are mutually exclusive? So are you able to simply just add 4 ace cards together with 26 red cards together? All right, so do leave your answer in the comments. All right, and then we will see how many of you actually understood the lesson so far. Hope you find this video useful. Do like and subscribe if this helped you. All right, I will see you in my next video. Bye.